Okay, our next lesson, lesson 10, sequences of rigid motions. So we've done sequences of translations, reflections, and rotations, and now we're combining them all for all of the rigid motions. So far we've seen how to sequence translations, reflections, and translations and reflections. And we know about rotation, and we can move geometric figures around the plane by sequencing a combination of translations, reflections, and rotations. So let's examine the following sequence, and you want to copy this on graph paper. So you might need to pause the video right now and draw something with the labels. Obviously, when you get to the ellipse, just guesstimate that as best as possible. All right, so if you're at this part, hopefully you have this picture drawn on graph paper. We're going to let E denote the ellipse in the coordinate plane as shown. So we're going to be talking about our figure E here. All right, so let translation 1 be the translation along the vector V from 1, 0 to negative 1, positive 1. And we're going to let rotation 2 be the 90-degree rotation around negative 1, positive 1. And then we're going to let reflection 3 be the reflection across line L joining negative 3, 0 and 0, negative 3. So here's our instructions. So what is a translation 1 of E, or figure E, followed by the rotation 2 of E, followed by the reflection 3 of E? Well, which transformation are we going to perform first? The translation, reflection, or rotation, and how do you know? And does it make a difference? All right, so the order in which transformations are performed does make a difference. Therefore, we perform the translation first. So now we let E1 be the translation of our first translation of E. So we were asked to translate if this is lining up with 1, 0, and we're going to translate it along a vector using our transparency. When we do that, it should end up somewhere around here right above the point negative 1, 1. So what are we going to do next? We are going to then rotate it. So we need to let E2, so here's E1, this is after the first transformation. E2 is going to be the image of E after the translation followed by a rotation. So now we're rotating it around point negative 1, 1. And again, using your transparency, if you did that, it's going to end up crossing with kind of the center of the ellipse being negative 3, positive 1. So now the only transformation left is reflection, and we let E3 be the image of E after the translation 1, followed by rotation 2, and followed by reflection of 3. So again, taking our transparency, if this is our line of reflection and we reflect it, it's going to end up in this area right here. All right, so let's take a look at the video again of the composition of rigid motions. And using our H again. Now you might be thinking, how come we don't reflect first or rotate first before we translate? Again, we don't know what our rotation is going to be until we can rotate to match 2 points, which will then form our line of reflection. And so then the last thing we do is the reflection. So it is important, the order. Whenever you don't have a coordinate plane or something to to give you any sort of sense of bearing, you always want to start with the translation first, because you can draw a vector between 2 points. Then the second thing you want to do is rotate until you match up the other points, which now forms a line, and then we can use that line as our line of reflection, and then the last motion we do is our reflection. All right, let's go ahead and flip back. So exercise 1, go ahead and answer exercise 1 first. It shouldn't take too long, and when you're done, continue the video. All right, for exercise 1, you should have said, yes, it's a reflection. That will map a triangle A prime, B prime, C prime, or triangle ABC onto A prime, B prime, C prime. So in this case, it would just be a reflection along this line right here, which is we would call BC or B prime, C prime. So the reflection requires some information about the line to reflect over. Can you provide a clear answer? And we just did. We're going to call that line BC because it is the line segment between point B and point C. So let there be a reflection across line BC. We claim that the reflection maps triangle ABC onto triangle A prime, B prime, C prime. And we can trace A prime, B prime, C prime on the transparency and see that when we reflect it across BC, A prime, B prime, C prime would map back onto ABC. So that is our proof. And the reason is because angle B prime and B are equal. We can look at any of the other angles. Angle or ray B prime, A prime on the transparency falls on ray BA. So you can look at angles, you can look at lines as to how they fall on, map onto each other. And similarly, ray C prime, A prime falls onto the ray CA. So by the picture, it's obvious that A prime on the transparency falls exactly on A, and so the reflection of triangle A prime, B prime, C prime across line BC is exactly triangle ABC. So we've picked a point, we've picked angles, and we've picked rays, and they all map onto each other. All right, for exercise 2, you should have said that the response would be a rotation. So to map A prime, B prime, C prime onto ABC would require a rotation. So rotation requires some information about what point to rotate around the center and how many degrees. If we say we need to rotate degrees, can you provide a clear answer? Well, we're going to rotate around point B because that was the point that they share in common. And because we don't know the amount of degrees, we're going to denote that as D. And we're not going to pull out our protractors and try to figure it out. We are just going to, whenever we don't know what the degrees are, we're just going to say we're rotating some number of degrees and we're going to call it D. So let there be a counterclockwise rotation. Remember, we got to designate the direction that we are rotating. So in this case, counterclockwise rotation of D degrees around B, where D is the positive degree of angle CB, C prime. We claim that the rotation maps angle A prime, B prime, C prime to triangle ABC. And again, we can trace the triangle on the transparency and see that when we pin it at point B, remember B prime is the same as point B, and perform the counterclockwise rotation of D degrees, that the segment B prime, C prime on the transparency maps onto segment BC. And both are equal in length because we can trace one on the transparency and show that it is the same length as the other. And then point A would map onto point A prime, or vice versa. And we also have a line BC, that would map onto each other. And if you look at exercise 1, it's the same thing. A prime, B prime, C prime is the same as ABC, and they completely coincide. All right, go ahead and do exercise 3. It's the last of the rigid motions. And when you're done, go ahead and continue. All right, so you should have rotate and reflect. So you're going to end up rotating the triangle and then reflecting it. All right. So what additional information do we need to provide for this? Well, we got to think back to the last 2 examples. First of all, we want to rotate around point B as the center, d degrees, and then we want to reflect across line BC. So you can also add in there that you're going to rotate around B, d degrees until C becomes or coincides with C prime. And that is going to cause a line called BC, and we're going to use it to reflect. So we need a sequence this time. First we're going to counterclockwise rotate d degrees around B, where d is a positive degree. Then we have angle CBC prime, and then we're going to reflect across the line BC. And we claim that the sequence rotation, then reflection maps A prime, B prime, C prime onto ABC. And again, we can prove this by tracing on our transparency, so that when we pin the transparency at B prime, which is the same as B, and perform the counterclockwise rotation, that the line segment B prime, C prime maps onto segment BC. And we know that they're in the exact position as the beginning of example 2 in exercise 1. So therefore, reflecting across line BC would map onto the transparency that triangle A prime, B prime, C prime is the same as triangle ABC. You may say that you want to reflect first and then rotate, but the sequence can be completed in that order, but we would need to state which line to reflect across. In that case, we have to find the appropriate line of reflection. For that reason, it makes more sense to bring the pair of sides together first, in this example B, C, and B prime, C prime, by a rotation, and then reflect across the common side of the 2 triangles. When the rotation is performed first, we can use what we know about exercise 1. So again, the whole idea of if you have nothing, no information, then you want to start with what can you create. You can't guess a line of reflection until you have a common line that you can talk about. All right, exercise 4, go ahead and try that. Again, keep in mind the order of the transformations that you need to do and why you need to do them. When you're done, go ahead and continue the video. All right, for exercise 4, you would have this. Scenario 1, we can translate and rotate, and in scenario 2, we can translate, reflect, and rotate. So again, the order does matter in this case. So what additional information is needed for the translation? Again, you need to create a vector, which is easy once you have 2 points. So there's no obvious vector in the picture, and so that's when you are drawing a vector that would map a point from A prime, B prime, C prime to a corresponding point in A, B, C. So you could draw a vector B prime B, or you can draw a vector A prime A, or you can draw a vector C prime C. Your choice. You get to pick in this case. So they decide to use B prime B. It makes the most sense because we can use the reasoning given in the previous examples rather than constructing the reasoning from the beginning. For example, in exercises 1 through 3, we already established the fact that B is the same as B prime. So let there be a translation along vector B prime B. In the first scenario, the triangles would be similar to the situation example 2. And in the second scenario, the triangles would be similar to the situation in example 3. And based on the work done in examples 2 and 3, we can conclude the following. that in scenario 1, the sequence of translation along vector b prime b followed by a rotation around b, or b prime, whichever you want to call it, would map the triangle a prime b prime c prime to triangle ABC. And in scenario 2, the sequence of a translation along b prime b followed by a rotation around b and finally followed by a reflection across line BC would map triangle a prime b prime c prime to triangle ABC. All right, go ahead and try using the language that we have been working on to map the figure onto the other location. This is going to be a little lengthy explanation, so make sure that you're including all the parts. When you are done, go ahead and continue the video. All right, so you should have a pretty good sized paragraph going on here. So let there be a translation along vector A prime. Now you could have done B prime. That is completely fine. This is one way you could have done it. They chose A prime. Then they decide to rotate. Once you have A prime on top of A, you can rotate around point A d degrees until you have a reflection. So, or once you find a reflection of a line. So in this case, they matched up A and B. So you're going to rotate until B prime becomes B, and that's going to form your line AB. So you're going to that translation of A prime to A, and then the rotation of B prime creates B, and also it creates a rotation of A prime B prime that coincides with AB. Reflect across line AB so that the reflection of C prime, point C, and C prime are equal to each other. And you can also talk about the fact that line segment CB is going to be the same as C prime B prime. So, and therefore the angle, whatever the angle of B is going to be the same as angle B prime. And you're probably not going to know that it's well, you do know it's 80 degrees. It's right here in the problem. So we know that because of all of these things, the points map onto each other, the rays or segments map onto each other, and the angles are the same. Therefore, we can, without a doubt, say that figure A prime, B prime, C prime is the same as ABC. So here is kind of a paragraph, a closed paragraph, that this is what it should look like for any sequencing of transformations. And you can copy this down and use this as your guide as you're answering the questions on describing how we're moving one shape onto another. You might need to pause the video in order to copy this down. All right, so if you have this copied down, let's go ahead and continue. And that is, we're going to finish up. We can now describe using precise language how to sequence rigid motions so that one figure maps onto another. And again, the key word here is precise language. You will be held to precision, so you want to make sure that you practice incorporating and including all of the elements to prove that one figure maps onto another. All right, we'll go ahead and see you in class.